Hello, ladies and gentlemen. This is pre-calc lesson 3. Today we will talk about the Pythagorean theorem and how it relates to triangle inequalities. And the similar shapes we will talk about will be similar triangles and similar polygons. Side note, you need a compass for lesson 4. You may also use a straight edge. You will need to bring it to class that day as well. But let's move on with lesson 3, Pythagorean theorem. Oops, spelled it wrong. Pythagorean theorem, not Pythagorean theorem. Pythagorean theorem, we have c squared equals a squared plus b squared. Now, this means nothing unless we relate it to what it is supposed to be, a triangle. Now, this is just any old triangle. When we say that c squared equals a squared plus b squared, we are talking about the fact that this relates to a right triangle. C is our hypotenuse, whereas A and B are just legs. Now, we will use the Pythagorean theorem to determine different triangle inequalities, but let's first talk about our triangle inequality postulate. A postulate, what is a postulate? A postulate is a statement that is true. The statement that is true that I'm going to tell you now is the sums of the lengths of any two sides of a triangle is greater than the length of the third side. The sums of the lengths of any two sides of a triangle is greater than the length of the third side. So if I had this triangle and I labeled this A, B, and C, this would tell me that A plus C must be greater, A plus B, must be greater than C. Or A plus C is greater than B, or B plus C is greater than A. We can use these three facts. This helps us determine if three numbers make a triangle. For example, if I gave you the numbers 4, 7, 8, is this a triangle? Or I guess we could say are 4, 7, 8 the legs of a triangle? Let's see. 4 plus 7, is that greater than 8? Yes. 11 is greater than 8. Now 4 plus 8, is that greater than 7? Yes. 12 is greater than 7. Okay. 7 plus 8, is that greater than 4? Yes. 15 is greater than 4. You can check my arithmetic to make sure I did that right. But then we could say, yes, 4, 7, and 8 can be a triangle. We can also use this fact, or the Pythagorean theorem and triangle inequality postulate, to determine if we have an obtuse triangle or an acute triangle. We call these the Pythagorean inequalities. Pythagorean inequalities. An obtuse triangle, we know that c squared is greater than a squared plus b squared. This would be an obtuse triangle. Again, the c relates to the longest side. Now, an acute triangle, c squared is less than a squared plus b squared. This is how we would determine if it is acute or obtuse. Now, here is an example. Okay, we have, this is example 3.1 from the book. We have the sides of a triangle 7, 5, and 4. And we want to know, is this triangle a right triangle, acute triangle, or obtuse triangle? Basically, we want to know 7 squared is what relation to 5 squared plus 4 squared? So 7 squared, 49, is something of 25 plus 16. And we know that then we have 49 is something of 41. And 49 is greater than 41, which tells us that this is an obtuse triangle. Pretty simple. The next thing, or the next section, is we have similar polygons. A polygon, poly meaning multi, right, is a simple closed figure whose sides are straight lines. For example, that is a polygon. Closed, meaning that it has all sides connecting. This is not a polygon because it is not closed. Now, we can talk about similar polygons. Similar polygons means that each polygon is a magnification or reduction of the other. We will do examples of this. And we know other facts is corresponding, which we know means in the same place. Corresponding angles are equal and corresponding sides are proportional. Those are facts of similar triangles. Those are also true, similar polygons. Those are also true of similar triangles. Similar triangles, we know that, again, the sides are related by a scale factor, same as with the polygons. And we also know that triangles are similar when corresponding angles are equal. This is true as well of similar polygons, but it is worth reiterating. Now let's look at example 3.2 from your book, which in my book is on page 30. And we have this shape going on. This side is 4, 5, angle here, here, x, 7, 6, y, and this angle here. We know that this angle and this angle are related because they have the double dash, and this angle and this angle are related. They have the single dash, which tells us that they are congruent. Now, a good way to do this is to redraw your two triangles. I'm going to do that here. If I draw with this angle here and this angle there, that means this is 4, this is x. That is 5. I'm going to redraw my other triangle. This angle there. I'm going to put my corresponding angles in the same place, meaning that is 7, this is y, this is 6. There are two ways that we can do this. We can either use a scale factor, or we can use proportions, or we call that ratios. I'm going to show you both. The scale factor, we can look at the relating sides here and here, and we say 5 times some scale factor that I'm labeling SF equals 7. So my scale factor SF is 7 over 5. I divide both sides by 5. That means then that if I multiply 4 by this scale factor, 7 over 5, it will give me y, because all the sides are related by the same scale factor. Therefore, y is 28 over 5. I can do the same thing for x. X times my scale factor 7 over 5 gives me 6. So then x is 6 times 5 over 7, which gives me 30 over 7. That is using a scale factor. Using proportions, I could say that 5 over 7 is the same as 4 over y. This is my ratio. And I'm going to cross multiply. I multiply the 5 by the y, giving me 5y, and the 7 times the 4 giving me 28. So I get y is 28 over 5. I can do the same thing for x. I can say 5 over 7 is the same as x over 6. Again, I cross multiply, giving me 30 equals 7x, so x is 30 over 7. Notice I get the same answer if I use different ways, and that is okay. You can use either way to do this. It does not matter. Let's do another example. Example 3.3. This is on page 31 in my book. I want to find x, y, and z, and I'm given this shape here. Again, I'm going to choose to redraw my triangles. I'm going to redraw them this way because that is the way we're most familiar with. Remember, if this side is opposite of the right angle, it has to stay opposite of the right angle. Pay attention to the orientation of your triangles. Again, 10 is opposite of my right angle here, therefore it is opposite of my right angle here. And I have 8 and z. I'm going to first solve for z because I can use the Pythagorean theorem. 8 squared plus z squared gives me 10 squared. Therefore, z squared is 100 minus 64. 10 squared minus 8 squared, which gives me 36. I take the square root of both sides, giving me that z is 6. Now I can use ratios or scale factor. I'm going to show you both. So the scale factor, I can say that 7 times some scale factor gives me 10. Therefore, my scale factor is 10 over 7. So then I can say x times my scale factor, 10 over 7, gives me the side of 8. Then, to solve for x, I multiply this and I say x is 8 times 7 over 10. I made a mistake. This is just so you learn. I did it on purpose. Maybe, maybe not. I'll let you be the judge of that. We know that these two angles right there are congruent, which here it is this angle here, but it is this angle here. So I should have drawn this triangle like this. Which means my scale factor is still true, but x times 10 over 7 should give me 6, not 8. Because of the orientation of my triangle. It is very important we are aware of the orientations of our triangles. Again, I did that mistake so you could learn, or that's going to be what we tell people. So then here I will get x is 42 over 10, which gives me x is 4.2. Still using scale factor, I then say y times my scale factor 10 over 7, that gives me 8. Therefore, y is 8 times 7 over 10. So y is 5.6. Now here we can also use ratios, and I can say that 7 over 10 is the same as x over 6. I get the 6 from z. I solved for z, which shows me that I can plug it in there. So I then get that x is, if I cross multiply, 10x is 7 times 6, which is 42, giving me that x is 4.2. I do the same thing for y, saying 7 over 10 is the same as y over 8. Therefore, 10y is 56, giving me that y is 5.6. Again, you should get the same answer whether you use scale factor or ratios. It does not matter. And again, we always make sure that we box our answers every time, without fail. All right, I am going to do another example. This is example 3.4, page 32. Yes, you need all of these in your notes. Here I have a triangle inside of a triangle. They are both right triangles. This is A, 6, 4, 4, B, C. Again, it is very important to redraw your triangles so that you can properly see which sides correspond. That's my little triangle. Now if I draw my big triangle, my bottom here is 10, 6 plus 4. My side here is C, and my top is A plus B. Very important you know what the triangle is. Now I'm going to solve for A. I know that A squared is 4 squared plus 6 squared. So A squared is 52. A is the square root of 52, which we simplify into 2 root 13. I hope you remember how to simplify. Now, this time, what I am going to do is, again, I can use ratios or proportions. I am just going to use, ratios or scale factor. I'm just going to use ratios. And I can say that 6 over 10 is the same as A over A plus B. It is very important that if I start with the little triangle, 6 to 10, I have little to big equals little to big. Keep your triangles in the same order. Again, I can cross multiply, so I have 6 times 2 root 13 plus B equals 20 root 13, or 10 times 2 root 13. This gives me 12 root 13 plus 6b equals 20 root 13. So 6b equals 8 root 13. I just subtracted 12 root 13 over. Don't get confused between my b's and 13s. And then I divide both sides by 6, leaving me with b equals 4 root 13 over 3. You can also write it as 4 over 3 root 13. Either one is fine. Now I'm going to solve for C the same way. 6 over 10 is 4 over C. I cross multiply. 6C is 40. So then C is 40 over 6. So C is 20 over 3. Now we have found A, B, and C. One more example. This is example 3.5, page 33 in your book. Here are my triangles. This is MK. This is a right angle. I have A, B, this angle here for H and 8. We want to find A, B, and H. I want you to try this problem on your own first. Then I will do it. First thing I'm going to do is I'm going to redraw my triangles. This time I have 3 triangles. If you are still working on the problem on your own, go ahead and pause the video, finish it, and then you may continue to listen to me and check your work. So I'm going to draw the big triangle first, where I see this is M and this is K. MK, I have 4 plus 8, giving me 12. And I have my sides A and B. Remember, pay attention, M to the right angle is side A. Keep your sides on the right place. Then I have my inner triangles. This one I have H, 4, and A. This is M. And my other triangle, this is H, 8, and B, this is K. Now, what I can do is I can solve this multiple ways. You may choose your favorite. What I am going to do is I am going to solve this using Pythagorean Theorem. So I can say that a squared is h squared plus 4 squared. I got that from this middle triangle. If I was to solve that, well, I'll leave it like that for now. I'm getting ahead of myself. Then this triangle over here, I can say that b squared is h squared plus 8 squared. And if I look at my big triangle, I have a squared plus b squared is 12 squared. I know what a squared is and I know what b squared is because I just solved for them, so I'm going to plug them in. A squared, I have h squared plus 16, or 4 squared. And b squared, I have h squared plus 64. And that equals my 12 squared, which is my 144. Now, what I can do is combine my terms. I have 2h squared plus 80 equals 144. And then I can move my 80 over, giving me that 2h squared equals 64. So h squared equals 32. H is the square root of 32, which we then simplify as h is 4 root 2. Now that I know h, I can plug h back in up here to solve for b and back in here to solve for a. So I get that a squared is h squared plus 16, and b squared is h squared plus 64. Now here, you don't even have to worry about squaring it because we already know what h squared is. So we get that a squared is 32 plus 16, giving me that a squared is 48. A is the square root of 48, which we of course simplify. You never leave anything unsimplified, into 4 root 3. Same thing for b squared. I get b squared is 32 plus 64, giving me that b squared is 96. So b is the square root of 96, which is 4 root 6. There you have it. Like I said, there are multiple ways to do this problem. If you want a different way to do it using ratios, you may look in your book. The book in example 3.5 uses ratios. I prefer to use Pythagorean Theorem, but either way is correct. Once you have this example down in your notes, that is all we have for today, and I will see you in class tomorrow.